Welcome to the Efficiency and Reliability Podcast. I'm your host, John. Today, we'll discuss the challenges refineries encounter with process tube oxidation in fired heaters and how high emissivity coatings can address these issues. In most cases, process tubes in fired heaters are made of steel alloy that experiences oxidation scale formation on the external surfaces under the operating conditions. Heavy scale creates poor conductive heat transfer through the tube wall to the process. This leads to overfiring and high bridgewall temperatures, eventually leading to a process limitation and reduced production rate. So the conditions of the tubes in the fired heaters can be, improved with a high emissivity thin film coating, which prevents oxidation and scale growth. It maintains maximum heat transfer efficiency for the life of the coating and eliminates production bottlenecks. Additional benefits can be provided by high emissivity ceramic coatings applied to the refractory surfaces, which improve radiant heat transfer efficiency to the process over design conditions and extend refractory life. Combined tube and refractory coatings can provide productivity benefits up to 15%, either saving energy or increasing throughput. In addition, significant reductions in environmental emissions have been achieved up to 15% CO2 and 25% NOx. The benefits may be demonstrated in a case study of a 4-cell fired heater of a catalytic reformer. All cells have double firing with burners located on floor. Tubes are 9% CR steel alloy, and walls and arch are insulated with castable refractory. The internal division walls and floor are made of insulating fire brick. Before the project, the refinery had searched for a solution to improve the heat transfer efficiency of its fired heaters and prevent any radiant tube oxidation. IGS thermal efficiency team evaluated the unit and determined that there is a potential gain on radiant efficiency of at least 11% from an application of CTEC coatings. High emissivity coatings were applied to all radiant surfaces in 3 of 4 heaters of a catalytic reformer during a major turnaround. A special ceramic coating system was selected for each type of surface. As a first step, tube surfaces were, prepared to meet the application standards. After that, a high emissivity tube coating was applied. The application took only 9 days, including all steps and phases. To accurately predict the anticipated outcomes following the application of high emissivity coatings, and infrared inspection was conducted on all process tubes. This assessment was coupled with collecting process data related to heater performance. Post-application, a significant improvement in radiant section heat transfer efficiency enabled fuel savings and/or an increase in, throughput, and provided a reduction in tube surface temperatures and bridgewall temperatures in all heater cells. There is a substantial reduction in tube surface temperatures averaging more than 100 degrees Celsius following the turnaround, particularly in the context of fuel savings. Furthermore, the temperature distribution along the length of the tubes became more uniform. The determination of tube metal temperature via ER thermography is notably more reliable after coating application, as the oxidation scale is eliminated and the coating's emissivity and temperature gradient are, well defined. The initial full data set was collected before the turnaround and compared with data after application. Process data shows that the application has improved radiant efficiencies and, debottlenecked the fired heater limitations. The CTEC coating application has accomplished the objectives of increasing fired heater efficiency and protecting process tubes from corrosion and oxidation, thereby prolonging tube service life. This project has provided an immediate economic benefit and long-term reliability for the refinery. It has achieved, 13.2% fuel savings under the same production or a corresponding production increase under the same fuel firing potential. Based on the fuel consumption reduction, the estimated CO2 savings are circa 9,600 million tons per annum, accompanied by thermal NOx emissions reduction due to lower radiant box temperatures. It is expected that the rapid scale oxidation trend that occurs in heater process tubes after conventional sandblasting will not be observed during the next 2 planned maintenance periods after the application, so it will not cause any production bottlenecks. Moreover, the next planned maintenance is expected to be shorter, minimizing downtime and turnaround costs since tube abrasive sandblasting is not needed. With the application of the high emissivity coating on the fired heaters, the environmentally friendly approach of the refinery and IGS has also been fulfilled. This approach can be expressed in the project's impact on greenhouse gas emissions and the energy intensity index. The project allowed the refinery to decrease fuel consumption by 4.7 gigacalories per hour while keeping the same conditions for the rest of the unit. This change reflected a CO2 gas emission drop of 9,600 million tons per annum. Regarding energy intensity index, and improvement of 0.31 was reported after the application. The application of C-Tech coatings brought an immediate radiant efficiency gain, as expected since a post-project analysis corresponded with a pre-project technical evaluation. 15 months after the project, the fired heater was revisited by C-Tech experts. The coating had no defects, continued to perform as planned, and bridgewall temperature stayed at the same level. The refinery has an option to save fuel, and the throughput increase option might be considered during high demand periods. As with all C-Tech applications, the unit's performance will be followed for the life of the coatings, and IGS engineers will undertake IR thermography inspections at regular intervals. And that's it for today's episode. Thank you for listening. Next week, we'll discuss a new case study. Once again, this is your host, John. If you'd like more content like this, please subscribe to this podcast or visit our website at www.integratedglobal.com.